Welcome to Cosmic Sleep, a channel where every story is a gentle journey into calm, wonder, and inner peace. If you enjoy exploring the mysteries of the universe in this way, consider subscribing, leave a like, and share your thoughts in the comments. Now take a slow breath and let's begin. But here's the question that has fascinated scientists, philosophers, and dreamers alike. Just how big is the universe? Is there an edge where space ends? Or does it go on forever, farther than our minds can even imagine? But here's the question that has fascinated scientists, philosophers, and dreamers alike. Just how big is the universe? Is there an edge where space ends, or does it go on forever, farther than our minds can even imagine? When you look up at the night sky, every star you see is like a tiny window into the unimaginable vastness of the universe. Here on Earth, as we breathe quietly under the dark canopy above, the distant glimmers of starlight traveling across millions, sometimes billions of years whisper to us about the sheer immensity of the cosmos. Scientists estimate that the observable universe spans nearly 93 billion light-years across, and yet they also remind us that this is likely just the portion we can see. Beyond that horizon, the universe may stretch on endlessly, a reality so vast that the human mind can barely begin to comprehend it. Imagine for a moment, if our entire solar system were reduced to the size of a grain of sand, the galaxy would be an entire beach, and the universe itself something far greater than all the oceans on Earth combined. In that perspective, our world feels small and yet deeply significant, because even though we are just a tiny part of this endless cosmic ocean, we are also inseparably woven into it. And perhaps that is the most comforting thought of all. We are not lost in the universe. We are the universe, looking back at itself. Take a deep breath and let yourself drift back to a time when humans first began to wonder about the true size of everything around them. Picture ancient Greece, where philosophers walked marble steps under star-filled skies, their minds already reaching beyond the horizon of what they could see. Aristotle believed the Earth was the center of everything, a small, finite sphere surrounded by crystalline spheres carrying the sun, moon, and stars. To him, the universe had boundaries, edges you could theoretically touch if you traveled far enough. But even then, there were whispers of something larger. Democritus, the man who first imagined atoms, also dared to suggest that there might be infinite worlds scattered throughout infinite space. As the Mediterranean breeze carried the scent of olive trees and salt air, he looked up at the same stars you see tonight and wondered if they were suns, burning bright above their own earths, their own seas, their own dreamers looking back. Now exhale gently and follow the rhythm of this journey as we move forward through time. Fast forward nearly 2,000 years and we find ourselves in the Renaissance, where a quiet monk named Giordano Bruno was asking dangerous questions. While candlelight flickered in monastery windows and church bells echoed across cobblestone streets, Bruno was writing words that would shake the foundations of human understanding. He proposed that the universe was infinite, filled with countless suns and worlds, each one a stage for life and wonder. For these ideas, Bruno was burned at the stake in 1600. But his thoughts survived, floating like seeds on the wind of human curiosity, waiting for the right moment to take root. That moment came with Galileo's telescope. Imagine the first night Galileo pointed his small, crude instrument toward the heavens. The year was 1609, and as the Italian countryside settled into evening quiet, broken only by the distant sound of crickets and the soft lapping of water against Venice's ancient stones, Galileo became the first human being to see that the Milky Way wasn't just a cloudy streak across the sky. It was made of stars. Thousands upon thousands of individual stars, each one a sun like ours, scattered across distances so vast that their combined light appeared as a gentle river of luminescence. Let your thoughts float like stars across the night sky and consider what this meant for humanity. For the first time, we had proof that the universe was far, far larger than anyone had imagined. Those weren't just decorative lights hung in the sky by gods. They were distant suns, perhaps warming distant worlds, perhaps shining down on other beings who were also looking up and wondering about the size of everything. As decades turned to centuries, more powerful telescopes revealed layer after layer of cosmic immensity. William Herschel, working by lamplight in his garden observatory in 18th century England, discovered that our Milky Way galaxy was disc-shaped, and that we were swimming somewhere within it, like fish, unaware they were living in an ocean. But the real revelation was still to come. In the 1920s, a young astronomer named Edwin Hubble was working at the Mount Wilson Observatory in California, night after night, as the Pacific fog rolled in over Los Angeles and the city lights dimmed to reveal the stars. Hubble was photographing what appeared to be fuzzy clouds in space, nebulae, astronomers called them. Most scientists believed these clouds were just gas formations within our own galaxy. But Hubble had a different suspicion, one that would forever change how we see our place in existence. Using the most powerful telescope of his time, Hubble began to measure the distance to these mysterious clouds. What he discovered was breathtaking. They weren't clouds at all. They were entire galaxies, island universes, each one containing hundreds of billions of stars, floating in the vast darkness of space like distant cities of light. Now take a deep breath and feel the silence of the cosmos as we absorb the magnitude of this discovery. Suddenly, the universe wasn't just big, it was almost incomprehensibly vast. If our galaxy contained 100 billion stars, and there were millions of other galaxies scattered throughout space, then the total number of stars in the universe was beyond counting. More stars than grains of sand on every beach on Earth. More stars than seconds that have passed since the universe began. But Hubble's discoveries didn't stop there. As he continued his observations, measuring galaxy after galaxy, he noticed something even more extraordinary. The galaxies were moving away from us. Not just drifting slowly, but racing away at incredible speeds. And the farther away a galaxy was, the faster it was retreating. This could only mean one thing. The universe itself was expanding. Picture space not as an empty box containing galaxies, but as the fabric of reality itself, stretching and growing like bread dough rising in a warm oven. Every point in space was moving away from every other point, carrying galaxies along like raisins in that cosmic dough. This discovery led to one of the most beautiful and profound realizations in human history. If the universe is expanding now, then it must have been smaller in the past, much smaller, infinitesimally smaller. Following this logic backward through time, scientists realized that everything we see, every star, every planet, every atom in your body, must have once been compressed into an incredibly hot, incredibly dense point, smaller than the period at the end of this sentence. And then approximately 13.8 billion years ago, that point began to expand in what we now call the Big Bang. Breathe slowly and let this image settle in your mind like starlight on still water. The Big Bang wasn't an explosion in space. It was the birth of space itself. Time began in that moment. The laws of physics awakened. The very concepts of here and there, of before and after, came into being as the universe inflated from nothingness into everything. In the first fraction of a second, the universe grew from smaller than an atom to larger than a grapefruit. In the first second, it cooled enough for the first particles to form. In the first few minutes, those particles combined to create the lightest elements, hydrogen and helium that would eventually become the raw materials for stars. For the first 380,000 years, the universe was opaque, filled with a glowing fog of particles and radiation. But as it continued to expand and cool, that fog finally cleared, releasing the first light that could travel freely through space. That ancient light is still traveling today. We can see it with our telescopes, a faint afterglow of creation itself, spread evenly across the entire sky. It's called the cosmic microwave background radiation, and it's like finding the fossil of the universe's infancy preserved in the very fabric of space. As you drift deeper into this cosmic journey, imagine what those first moments must have been like. No stars yet, no galaxies, no planets, just pure energy and possibility expanding into the darkness, carrying within it everything that would ever exist. Within that primordial fire were the atoms that would one day form the earth beneath your feet, the water in your body, the oxygen in your lungs, the calcium in your bones was forged in the heart of dying stars. The iron in your blood was scattered into space by ancient supernovas. You are literally made of stardust, a poetic truth that science has revealed to be absolutely literal. Let your breath slow and deepen as we prepare to explore just how large this expanding universe has become. From Hubble's first measurements in the 1920s to today's most advanced space telescopes, astronomers have been pushing deeper and deeper into space, mapping the cosmic landscape with ever-increasing precision. What they've discovered is a universe of almost incomprehensible scale. The observable universe, the portion we can actually see, stretches for about 46.5 billion light-years in every direction from Earth. That might seem confusing, since the universe is only 13.8 billion years old. How can we see farther than light has had time to travel? The answer lies in the expansion of space itself. Imagine you send a letter to a friend, but while the letter is traveling, your friend moves to a house much farther away. When the letter finally reaches them, they'll be much farther from you than they were when you sent it. Similarly, the light from distant galaxies has been traveling toward us for billions of years, but during that time, those galaxies have been carried farther away by the expansion of space. This gives us an observable sphere around Earth, with a radius of about 46.5 billion light-years. Within this sphere, we can count approximately 2 trillion galaxies, each containing hundreds of billions of stars. The total number of stars in the observable universe is estimated to be around 1024. That's a 1 followed by 24 zeros. To put this in perspective, if every star were a grain of sand, the observable universe would contain more sand than exists on every beach, in every desert, on every planet in our solar system. But here's what makes this truly awe-inspiring. The observable universe might be just a tiny fraction of the whole. Think about standing in the middle of an enormous ocean on a foggy day. You can only see a certain distance before the fog blocks your view. That's your horizon, but you know the ocean continues far beyond what you can see. The observable universe is like that horizon. It's not an edge where space ends, it's just the limit of how far we can see. Beyond our cosmic horizon, the universe likely continues, possibly forever. Some theories suggest the universe is infinite in size, stretching on without end in all directions. Others propose it might be finite, but unbounded, like the surface of a sphere. A being walking on a sphere can travel forever without reaching an edge, yet the total surface area is finite. Recent measurements from space missions like Planck and WMAP have studied the cosmic microwave background radiation with extraordinary precision, looking for clues about the universe's overall geometry. The data suggests that space is very nearly flat, which in cosmological terms means it could indeed be infinite. Exhale gently and let your mind rest in the vastness of this possibility. If the universe is truly infinite, then everything that can happen will happen and has happened countless times. There would be infinite copies of Earth, infinite versions of you, infinite variations on every possible story. The number of ways atoms can be arranged is vast, but finite, so in an infinite universe, every possible arrangement would occur infinite times. This isn't science fiction, it's a serious consequence of inflation theory, one of our best models for how the universe began and evolved. According to this theory, the Big Bang wasn't a single event, but rather our local expansion of space from a much larger, eternally inflating cosmos. Picture a pot of boiling water with bubbles constantly forming and expanding. Each bubble might represent a universe like ours, with its own physical laws, its own galaxies, its own stories unfolding. We would be living inside just one of these bubbles, unaware of the countless others expanding around us in higher dimensional space. These other universes, if they exist, would be completely inaccessible to us. No light, no information, no influence could pass between them. Each would be its own complete reality, as real and valid as our own. As the night deepens around us and distant city lights twinkle like earthbound stars, we find ourselves contemplating not just one universe, but possibly infinite universes, each one containing infinite worlds, infinite possibilities, infinite stories of consciousness awakening to question its place in the cosmic order. The ancient Greek philosophers, who first wondered about infinity, could never have imagined where their questions would lead. From the simple observation that stars exist, humanity has built a picture of reality so vast and magnificent that it challenges the very limits of comprehension. And yet, as overwhelming as these scales might seem, there's something deeply comforting about our cosmic situation. We are not separate from this universe, we are expressions of it. The same physical laws that govern distant galaxies also govern the beating of your heart. The same forces that shape the cosmic web of dark matter also guide the dance of electrons around atomic nuclei in your brain. You are not a tiny, insignificant speck lost in an indifferent cosmos. You are the cosmos itself, organized into a form complex enough to contemplate its own existence, to feel wonder at its own vastness, to experience love and beauty and the gentle peace of a quiet night spent gazing at stars. In the next part of our journey, we'll explore how scientists measure these cosmic distances and what new telescopes are revealing about the farthest reaches of space and time. We'll discover galaxies so distant that their light began its journey when the universe was still young, and we'll contemplate what it means to see so far back in time that we're witnessing the universe's own childhood. Now take a deep breath and feel the silence of the cosmos as infinite space and time cradle us in their gentle embrace. Now take a deep breath and feel the silence of the cosmos as we begin to understand how astronomers measure the immeasurable. The gentle peace of infinite space and time cradles us as we journey deeper into one of the most beautiful aspects of cosmic exploration, the way light itself becomes a time machine, carrying messages from the deepest past across the vast oceans of space. Imagine you're sitting by a calm lake at twilight, watching ripples spread across the water's surface. Each ripple carries information about what created it: a fish jumping, a stone thrown, a gentle breeze. In much the same way, light carries information across the universe, but with one extraordinary difference: light travels at a finite speed. This simple fact transforms every telescope into a time machine and every astronomer into an archaeologist of light. When you look at the sun, you're seeing it as it was 8 minutes ago, the time it takes light to travel the 93 million miles between the sun and Earth. When you gaze at the nearest star, Proxima Centauri, you're seeing light that began its journey over 4 years ago. Look at the Andromeda Galaxy, that faint smudge, visible to the naked eye on clear nights, and you're witnessing photons that have been traveling for 2.5 million years. Let your thoughts float like starlight across the darkness and consider what this means for our understanding of cosmic scale. The farther we look into space, the farther back in time we see. Our most powerful telescopes don't just reveal distant galaxies, they show us the universe as it was billions of years ago, when galaxies were younger, when stars were forming at different rates, when the cosmos itself was smaller and denser and dramatically different from today. This is how astronomers have learned to measure the universe, not with rulers or measuring tapes, but with light itself, using the stories that photons tell us about their long journeys across space and time. The first step in this cosmic archaeology was understanding stellar brightness. In the early 1900s, a brilliant astronomer named Henrietta Swan Leavitt was working at the Harvard College Observatory, carefully studying photographic plates of stars in the Magellanic Clouds. Night after night, as Cambridge settled into quiet darkness punctuated only by the distant sounds of the city, Leavitt was making a discovery that would become one of the fundamental tools for measuring cosmic distances. She noticed that certain stars, called Cepheid variables, pulsed with a regular rhythm, growing brighter and dimmer in a predictable cycle. More importantly, she discovered that the brighter these stars were intrinsically, the longer their pulsation period. This relationship became known as the Leavitt law, and it gave astronomers their first reliable way to measure distances to far-off galaxies. Here's how it works. If you can identify a Cepheid variable star in a distant galaxy, you can measure its pulsation period. That tells you how bright the star actually is. Compare this to how bright it appears from Earth, and the difference tells you how far away it must be. The same way a candle appears dimmer, the farther away you hold it. Breathe slowly and let this elegant solution settle in your mind like morning dew on grass. This was the technique Edwin Hubble used to prove that spiral nebulae were actually separate galaxies. By finding Cepheid variables in what we now know as the Andromeda Galaxy, he calculated that it was nearly 1 million light-years away, far beyond the boundaries of our own Milky Way. Modern measurements put Andromeda at about 2.5 million light-years distant, but Hubble's pioneering work established the method. As telescopes became more powerful and techniques more refined, astronomers developed what they call the cosmic distance ladder, a series of methods that build upon each other to measure ever greater distances. For nearby stars, we can use parallax, the apparent shift in a star's position as Earth orbits the Sun. Hold your finger in front of your face and close one eye, then the other. Notice how your finger appears to jump back and forth against the background. That's parallax, and it works for stars too, though the shifts are incredibly tiny, like trying to measure the width of a coin from 100 miles away. For more distant objects, we use those Cepheid variable stars. For even greater distances, we employ type Ia supernovas, the explosive deaths of white dwarf stars. These cosmic lighthouses are so bright they can be seen billions of light-years away, and they all have nearly the same intrinsic brightness, making them excellent standard candles for measuring cosmic distances. As we climb this distance ladder, rung by rung, the universe reveals its true immensity. But with each measurement, we also peer deeper into cosmic history. Exhale gently and follow the rhythm of this journey as we travel to the very limits of what we can see. The most distant galaxies we can observe existed when the universe was less than 1 billion years old, cosmic toddlers compared to the 13.8 billion-year age of the cosmos today. These ancient galaxies appear red-shifted, their light stretched to longer, redder wavelength by the expansion of space itself. This redshift is like a cosmic Doppler effect. Just as the sound of a train horn drops in pitch as the train moves away from you, the light from distant galaxies is stretched to redder colors as they race away from us, carried by the expansion of space. The most distant galaxy ever observed, GNZ11, has a redshift so extreme that we're seeing it as it was just 400 million years after the Big Bang. The light we receive from this galaxy today began its journey when the universe was only 3% of its current age, a cosmic infant still glowing with the warmth of creation. But even GNZ11 isn't at the absolute edge of what we can potentially see. The farthest we can look back in time is to the cosmic microwave background radiation, that ancient afterglow from when the universe first became transparent, about 380,000 years after the Big Bang. Picture the early universe as a dense, hot fog. For hundreds of thousands of years after the Big Bang, space was filled with free electrons and protons swimming in a sea of intense radiation. Any photon trying to travel through this cosmic soup would immediately collide with an electron and scatter in a random direction, like someone trying to use a flashlight in thick fog. But as the universe expanded and cooled, something magical happened. The temperature dropped just enough for electrons and protons to combine into neutral hydrogen atoms. Suddenly, space became transparent. For the first time, light could travel freely across the cosmos. The photons released in that moment of cosmic transparency have been traveling ever since, stretched by the expansion of space from visible light to microwaves, creating a faint glow that fills the entire sky. When you tune an old television between channels and see static, about 1% of that static is actually ancient light from the Big Bang itself. Now take a deep breath and feel the profound connection between your living room and the birth of the universe. This cosmic microwave background is remarkably uniform, the same temperature in every direction to within a few parts in 100,000. But those tiny variations, like whispers in the static, tell us enormous amounts about the early universe. They show us the seeds that would eventually grow into galaxies, the quantum fluctuations that were stretched to cosmic scales by inflation, the very blueprint from which all large-scale structure in the universe would emerge. Modern space telescopes have mapped this ancient light with extraordinary precision. The Planck satellite, launched by the European Space Agency, created the most detailed map ever made of the cosmic microwave background, like archaeologists carefully brushing dust from an ancient artifact. Scientists analyzed every subtle variation in temperature across the sky. What they found was a universe that is 68.3% dark energy, 26.8% dark matter, and only 4.9% ordinary matter, the stuff that makes up stars, planets, and you. The geometry of space appears to be flat, suggesting the universe might indeed be infinite in size. And the data confirms that cosmic inflation, that brief period of exponential expansion in the first fraction of a second, really did happen. But the cosmic microwave background also reveals something deeply moving. The universe was once small enough and young enough that every part could communicate with every other part. The uniformity we see today is evidence that the entire observable universe was once in causal contact, a single, connected system before inflation stretched it beyond the limits of light-speed communication. Let your mind rest in the gentle unity of this ancient connection as we contemplate what lies beyond our horizon. Even our most powerful telescopes will never see beyond the cosmic microwave background. The universe before that time was opaque to light, shrouded in the fog of free particles and radiation. But scientists are developing new ways to probe even deeper into cosmic history. Gravitational wave detectors like LIGO and Virgo can potentially detect ripples in space-time from the earliest moments after the Big Bang. Gravitational waves that would have been produced during inflation itself. Future space-based detectors might hear the gravitational wave echo of cosmic birth, giving us a new window into the universe's infancy. Neutrino telescopes buried deep underground or sunk in Antarctic ice can catch ghostly particles that barely interact with matter, allowing them to carry information from the cores of stars and the hearts of supernovas across billions of light years without being absorbed or scattered. Even more exotic possibilities await. Some theories suggest that dark matter particles might occasionally annihilate each other, producing high-energy gamma rays that we could detect. Others propose that the vacuum of space itself might contain signatures of extra dimensions or parallel universes. As technology advances and our techniques become more sophisticated, we're beginning to detect objects and phenomena that push the very limits of cosmic distance and time. The James Webb Space Telescope, with its golden mirror nearly 22 feet across, can see farther into space and deeper into time than any previous instrument. Breathe deeply and imagine what new horizons await us in the gentle darkness. Webb's infrared vision allows it to peer through cosmic dust and see the formation of the first stars and galaxies. It can analyze the atmospheres of planets orbiting other stars, searching for signs of water vapor, oxygen, and other molecules that might indicate life. It can study the supermassive black holes that lurk at the centers of galaxies, watching as they devour matter and launch jets of particles across millions of light years. But perhaps most remarkably, Webb is showing us galaxies that are larger and more mature than we expected to find so early in cosmic history. Some of these ancient galaxies contain billions of stars and show signs of complex structure, spiral arms, central bulges, evidence of mergers and interactions. This is reshaping our understanding of how quickly the universe evolved from the smooth, nearly featureless state revealed by the cosmic microwave background to the rich tapestry of galaxies we see today. It suggests that the processes of star formation, galaxy assembly, and cosmic evolution were more efficient in the early universe than we previously thought. These discoveries remind us that the universe is still full of surprises, still capable of challenging our assumptions and expanding our sense of wonder. Every new telescope, every improved technique, every deeper observation reveals aspects of cosmic reality that no one expected. Consider the scale of what we're attempting. We're trying to measure a universe that might be infinite, using instruments built on a small rocky planet orbiting an ordinary star in the suburbs of a typical galaxy. We're trying to understand the history of everything from our vantage point in a single moment of cosmic time, and yet we're succeeding. Through the patient accumulation of observations, the careful development of theory, and the ingenious application of physical laws, we're mapping the cosmos with increasing precision and detail. Exhale slowly and feel the quiet satisfaction of human curiosity reaching across the vastness. The cosmic distance ladder now extends from parallax measurements of nearby stars to observations of galaxies so distant their light has been traveling for over 13 billion years. We can map the positions of millions of galaxies, trace the web-like structure of dark matter that scaffolds the universe, and measure the rate of cosmic expansion with remarkable accuracy. We know that the universe is not only expanding, but that this expansion is accelerating, driven by the mysterious dark energy that makes up more than 2/3 of everything that exists. We can calculate that if you traveled at the speed of light, it would take you 46.5 billion years to reach the edge of the observable universe, assuming you could somehow travel in a straight line through expanding space. But the true edge of the universe, if it has one, remains beyond our reach, possibly beyond the reach of any observer anywhere in the cosmos. If space is truly infinite, then no matter how far you traveled, there would always be more galaxies ahead, more stars to discover, more worlds where other beings might be looking up at their own night sky and wondering about the size of everything. This is both humbling and exhilarating. We are cosmic beings, forged in stellar furnaces, contemplating infinity from our small but precious perch in space and time. We are the universe's way of knowing itself, of measuring its own vastness, of feeling wonder at its own magnificent complexity. In our next chapter, we'll explore what fills the vast spaces between galaxies, the invisible scaffolding of dark matter and dark energy that shapes cosmic structure. We'll journey into the cosmic web, that beautiful tapestry of matter and void that connects everything in the universe in an intricate dance of gravity and expansion. Now, let your breath slow and deepen as we prepare to explore the hidden architecture that binds the cosmos together, the invisible threads that weave galaxies into the grandest structure of all. Now, let your breath slow and deepen as we prepare to explore the hidden architecture that binds the cosmos together, the invisible threads that weave galaxies into the grandest structure of all. As we journey deeper into the cosmic darkness, guided by the gentle light of distant stars, we discover that the universe is not simply a random scattering of galaxies across empty space. Instead, it's organized into a magnificent web of matter and void, a cosmic tapestry so vast and intricate that it challenges our very understanding of structure and scale. Imagine standing on a mountaintop on a clear winter night, looking down at a city spread out below. From that distance, you can see the patterns of streets and neighborhoods, the way highways connect different districts, the dark spaces of parks and rivers threading between areas of bright lights. The universe, when viewed on its largest scales, reveals a similar kind of organization, a cosmic cityscape written in galaxies and dark matter. This is the cosmic web, and it's one of the most beautiful and mysterious aspects of our universe. To understand how this web formed, we need to journey back to those tiny variations in the cosmic microwave background, those whisper-soft fluctuations in temperature that we discussed earlier. Like seeds planted in cosmic soil, these microscopic variations in the density of matter would grow over billions of years into the largest structures in the universe. Picture the early universe as a vast ocean of dark matter, ordinary matter, and radiation gently rippling with quantum fluctuations. Dark matter, which interacts only through gravity, began to clump together in the regions where density was slightly higher. As these clumps grew, their gravity attracted more matter, creating an ever-strengthening web of invisible scaffolding. Breathe slowly and let your mind drift through this ancient process of cosmic construction. Dark matter makes up about 27% of the universe, yet it remains one of the most enigmatic substances we know. It doesn't emit light, doesn't absorb light, doesn't interact with electromagnetic radiation in any way we can detect. We know it exists only because of its gravitational effects, the way it bends light from distant galaxies, the way it influences the rotation of spiral galaxies, the way it shaped the growth of cosmic structure. Think of dark matter as the universe's invisible sculptor, while ordinary matter, the protons, neutrons, and electrons that make up stars, planets, and you, makes up less than 5% of the cosmic inventory. It's the dark matter that provides the gravitational framework around which everything else organizes. Computer simulations of cosmic evolution, running on the world's most powerful supercomputers, reveal how this invisible web developed over billions of years. Starting from those tiny quantum fluctuations, dark matter gradually assembled into long filaments, stretching across hundreds of millions of light-years, connected by massive nodes, where galaxy clusters would eventually form. The ordinary matter followed the dark matter's lead, flowing like cosmic rivers along these invisible highways, pooling in the deepest gravitational wells, where it could cool, condense, and eventually ignite into the first stars. Now take a deep breath and feel the universe organizing itself around us through the patient work of gravity and time. When astronomers began mapping the positions of millions of galaxies in three-dimensional space, they discovered that this cosmic web isn't just a theoretical prediction, it's a magnificent reality. Galaxies are arranged in vast filaments and sheets, separated by enormous voids where very few galaxies exist. The Sloan Digital Sky Survey, one of the most ambitious mapping projects in astronomy, has plotted the positions of over 1 million galaxies, revealing the cosmic web in stunning detail. When you look at these maps, you see something that resembles neural networks in a vast cosmic brain, or perhaps the foam structure you might see in a saying full of soap bubbles. The filaments of the cosmic web can stretch for hundreds of millions of light years, while the voids between them can be even larger. Cosmic deserts so empty that a being living in the middle of one might see only a handful of distant galaxies scattered across their entire sky. Our own Milky Way galaxy sits on a filament called the local sheet, part of a larger structure known as the Laniakea supercluster. This supercluster contains over 100,000 galaxies spread across 520 million light-years, all connected by the invisible threads of dark matter and held together by their mutual gravitational attraction. Let your thoughts float like cosmic dust along these vast filaments as we contemplate the forces that shape such enormous structures. The cosmic web is not static, it's a dynamic, evolving system where matter flows along filaments toward the nodes, feeding the growth of galaxy clusters and supermassive black holes. Some filaments merge and grow stronger, while others may be stretched thin by the expansion of space. At the intersections of major filaments, where multiple streams of dark matter converge, we find the largest gravitationally bound structures in the universe, galaxy clusters. These cosmic metropolises can contain thousands of galaxies, each one comparable to our entire Milky Way, all bound together by gravity and swimming in vast halos of dark matter. The Coma Cluster, one of the nearest large galaxy clusters, contains over 1,000 galaxies in a region about 20 million light-years across. The total mass of this cluster is about 100 trillion times the mass of our Sun, with most of that mass in the form of invisible dark matter. Galaxy clusters are like cosmic laboratories where we can study matter under the most extreme gravitational conditions. When clusters collide, a process that takes hundreds of millions of years, they create some of the most energetic events in the universe since the Big Bang itself. The Bullet Cluster, formed by the collision of two galaxy clusters about 150 million years ago, has provided some of the most direct evidence for dark matter. When astronomers studied this cosmic crash site, they found that the ordinary matter, heated to millions of degrees and glowing in X-rays, had been slowed down by the collision, but the dark matter, interacting only through gravity, had passed right through, separating from the ordinary matter and revealing itself through its gravitational lensing effects. Exhale gently and consider how cosmic collisions help us understand the invisible universe. But the cosmic web holds an even deeper mystery: the voids. These enormous empty regions, some hundreds of millions of light-years across, contain very little matter of any kind. They're not completely empty. A few lonely galaxies drift through these cosmic deserts like islands in vast, dark seas, but they're as close to nothingness as anything we know in the universe. The largest void discovered so far, the Bootes void, is sometimes called the Great Nothing. It's a spherical region of space, roughly 330 million light-years in diameter, containing almost no galaxies. If Earth were at the center of the Bootes void, we wouldn't have discovered other galaxies until the 1960s, because the nearest large galaxy would have been barely visible to our telescopes. These voids aren't just empty space. They're regions where the expansion of the universe has stretched the original small variations in matter density until almost nothing remains. They're growing larger as cosmic expansion continues, pushing their few remaining galaxies farther apart. Standing in such a void would be one of the most profound and lonely experiences possible in our universe. The night sky would be nearly black, containing perhaps a few dozen faint, distant galaxies scattered across the entire heavens. There would be no Milky Way stretching across the sky, no nearby galaxies to admire, no sense of cosmic community. Just vast, overwhelming darkness and the profound silence of nearly empty space. Yet, even in these cosmic deserts, dark energy continues its mysterious work, driving the acceleration of cosmic expansion and ensuring that the voids will continue to grow larger and emptier as billions of years pass. Now, take a deep breath and feel the vast emptiness and fullness of space flowing around us like cosmic tides. Dark energy remains the greatest mystery in modern cosmology. Making up about 68% of the universe, it's a form of energy that fills all of space and tends to accelerate the expansion of the universe. Unlike dark matter, which clumps and forms structure, dark energy appears to be perfectly smooth, providing a constant energy density throughout space. The discovery of dark energy came as a complete surprise. In the 1990s, two teams of astronomers were studying distant supernovas, expecting to find that the expansion of the universe was slowing down due to the gravitational pull of all the matter it contains. Instead, they found that the expansion was speeding up. Picture the universe as a ball thrown into the air. Gravity should slow it down, eventually bringing it to a stop and pulling it back down. But what astronomers discovered was equivalent to watching the ball accelerate upward, as if some invisible force was pushing against gravity and driving the expansion faster and faster. This acceleration began relatively recently in cosmic history, about 5 billion years ago. Before that, matter and radiation dominated the universe, and expansion was indeed slowing down. But as space expanded and matter became more dilute, the constant energy density of dark energy eventually took over, beginning the current era of accelerated expansion. If dark energy continues to dominate, the far future of the universe will be very different from its past. Galaxies outside our local group will eventually disappear beyond our cosmic horizon, carried away by the accelerating expansion of space. The cosmic web will be stretched and torn apart. Stars will eventually exhaust their fuel and burn out, leaving behind white dwarfs, neutron stars, and black holes. But that future is unimaginably distant. Trillions of years in the future, a span of time so long that the entire history of the universe so far would be just the first page in a cosmic story stretching across countless volumes. Let your mind rest in the vast scales of cosmic time as we contemplate our place in this expanding web. For now, we live in what might be called the golden age of cosmic structure. The cosmic web is fully developed, galaxy formation is still active, stars are still being born in vast nurseries of gas and dust. The universe is old enough to have developed complexity, but young enough to still be dynamic and evolving. Our solar system formed about 4.6 billion years ago in a spiral arm of the Milky Way, which itself is moving through space at about 600 kilometers per second toward the Virgo cluster as part of the general flow of matter along cosmic web filaments. We are passengers on spaceship Earth, which is orbiting a star that is orbiting the center of a galaxy that is falling through space along invisible rivers of dark matter. This movement through the cosmic web creates what astronomers call our cosmic address. Just as you might live at a specific house on a specific street in a specific city, in a specific country, we have a cosmic address that stretches from Earth to the largest scales of structure in the universe. Earth orbits the Sun, which is one star among 400 billion in the Milky Way galaxy. The Milky Way is part of the Local Group, a small collection of about 100 galaxies dominated by ourselves and the Andromeda Galaxy. The Local Group is part of the Virgo supercluster, which contains about 1,1300 galaxies spread across 1,110 million light-years. But recent discoveries have revealed that the Virgo supercluster is itself just one part of an even larger structure called Laniakea, Hawaiian for immense heaven, which contains about 100,000 galaxies in a region 520 million light-years across. And Laniakea is connected to other superclusters through the filaments of the cosmic web, creating a hierarchy of structure that extends to the largest scales we can observe. Breathe deeply and feel your connection to this vast cosmic architecture. The beautiful thing about the cosmic web is that it connects everything. The same gravitational forces that keep you anchored to Earth also guide the motion of galaxies across billions of light-years. The dark matter that we can't see directly provides the invisible foundation for the galaxy in which you live. The dark energy that drives cosmic acceleration also influences the space between atoms in your body, though so weakly that you'll never notice it. You are not separate from the cosmic wave, you are part of it. The calcium in your bones, the iron in your blood, the oxygen you breathe, were all forged in the nuclear furnaces of stars that formed within this web of dark matter. Those stars exploded as supernovas, scattering their enriched material into space, where it eventually condensed into new stars, planets, and ultimately into you. The cosmic web is not just a map of where galaxies live, it's a family tree of everything that exists. Every atom in your body can trace its history back through the web, through stellar explosions and gravitational collapse, through the formation of the first stars and the growth of the first dark matter structures, all the way back to the quantum fluctuations that rippled through space in the first fraction of a second after the Big Bang. Recent observations are revealing new details about how matter flows through the cosmic web. Using advanced telescopes and computer simulations, astronomers can now track the movement of gas and galaxies along filaments, watching as matter streams toward massive clusters and feeds the growth of supermassive black holes. Some of these streams of matter are so vast that they contain more mass than billions of suns, flowing like cosmic rivers along dark matter highways. When this matter reaches a galaxy cluster, it can trigger bursts of star formation, fuel the growth of central black holes, and create spectacular displays of high-energy radiation visible across billions of light-years. The Hubble Space Telescope and other advanced instruments have captured images of these cosmic streams, showing glowing tendrils of gas stretched across millions of light-years, connecting distant galaxies like luminous bridges spanning the darkness. Exhale slowly and let the interconnectedness of cosmic structure flow through your awareness. As our understanding of the cosmic web deepens, we're beginning to realize that it's not just a passive framework for galaxy formation, it's an active, dynamic system that continues to evolve and influence the development of structure throughout the universe. The web feeds supermassive black holes, channels star formation, and creates the conditions for galaxy mergers and interactions. It determines which regions of space will remain empty and which will become the sites of future cosmic cities. It even influences the formation of smaller structures like star clusters and planetary systems. In a very real sense, the cosmic web is the universe's nervous system, connecting distant regions through gravitational influences and matter flows, allowing information and energy to propagate across cosmic scales. Just as neurons in a brain are connected by synapses that allow thoughts and memories to emerge, the cosmic web connects galaxies and galaxy clusters in ways that allow large-scale structure and cosmic evolution to unfold. This perspective suggests that the universe itself might be thought of as a kind of cosmic organism, with the cosmic web as its infrastructure, galaxies as its organs, and stars as its cells. We are not just observers of this cosmic organism, we are part of it, conscious elements within a vast, evolving system of matter, energy, and information. In our final chapter, we'll explore what the future holds for this cosmic web, how dark energy will continue to reshape the universe, and what it means to be conscious beings embedded within such a magnificent and mysterious cosmic structure. We'll contemplate the deep connections between the very small and the very large, between quantum mechanics and cosmic evolution, between the consciousness in your mind and the vast intelligence that seems to emerge from the universe as a whole. Now let your thoughts drift like galaxies along invisible filaments as we prepare for the final stage of our cosmic journey through infinite space and time. Now, let your thoughts drift like galaxies along invisible filaments as we prepare for the final stage of our cosmic journey through infinite space and time. As we reach the end of our exploration into the vastness of the universe, we find ourselves standing at the edge of forever itself, contemplating what it truly means to exist within something that may have no boundaries, no ending, no final page in its cosmic story. The gentle darkness around us holds not just the light of distant stars, but the profound mystery of infinity, a concept so vast that it transforms everything we think we know about existence, consciousness, and our place in the grand scheme of reality. Take a deep breath and let yourself drift into the infinite possibilities that surround us. Throughout our journey, we've traced the universe from its smallest quantum fluctuations to its largest structures, from the microscopic seeds that grew into galaxies to the cosmic web that connects everything across billions of light years. We've seen how human curiosity has gradually unveiled layer after layer of cosmic truth, each discovery revealing that the universe is far stranger, far more beautiful, and far more vast than we ever imagined. But now we must grapple with perhaps the most profound question of all. If the universe truly is infinite, what does that mean for everything we are and everything we might become? In an infinite universe, every possible arrangement of matter and energy doesn't just exist somewhere, it exists in infinitely many places. The laws of physics are finite in their complexity, and matter can only be arranged in so many ways. In infinite space, every possible pattern must repeat infinitely often. This means that somewhere in the vast expanse beyond our cosmic horizon, there is another galaxy, identical to the Milky Way, another solar system identical to ours, another Earth, where another version of you is listening to these very words. Not just one other Earth, but infinitely many, with infinitely many variations on the story of your life. Let your mind float gently with this impossible thought, like starlight drifting through endless space. In some of these infinite Earths, you made different choices. In others, history unfolded differently. Perhaps dinosaurs never went extinct. Perhaps humans developed different technologies. Perhaps the laws of physics are subtly different in ways that allow for entirely new forms of matter and energy. This isn't science fiction, it's a serious consequence of cosmic inflation theory, one of our best models for how the universe began. If inflation is correct, then our observable universe is just one bubble in an eternally inflating cosmic foam, with new universes constantly being born, each potentially with its own physical laws and its own infinite possibilities. But infinity isn't just about space, it's also about time. Current evidence suggests that the universe will continue expanding forever, driven by dark energy toward an increasingly cold and empty future. Yet even in that far future, quantum mechanics ensures that the vacuum of space will continue to fluctuate, occasionally creating new particles, new structures, perhaps even new pockets of space-time where complexity can emerge once again. Given infinite time, Quantum fluctuations could theoretically recreate any configuration of matter, including exact copies of our current universe. The mathematician and physicist Max Tegmark has calculated that a quantum fluctuation identical to your current brain state would occur randomly about once every 50 years, a time span so vast that it makes the current age of the universe seem like the blink of an eye. Breathe slowly and let these vast timescales wash over you like cosmic tides. But perhaps the most beautiful aspect of cosmic infinity isn't the repetition of patterns, but the endless creativity it allows. In infinite space and time, not only does everything that can happen, but new possibilities are constantly emerging as the universe explores every conceivable form of organization, consciousness, and beauty. Consider consciousness itself, the very awareness with which you're contemplating these words. Science still doesn't fully understand how matter and energy organize themselves into systems capable of subjective experience, of wonder, of love. Yet here we are, arrangements of carbon, hydrogen, oxygen, and other elements that have somehow awakened to contemplate their own existence. If consciousness can emerge once in the universe, then in infinite space, it must emerge infinitely often, in forms we can barely imagine. There may be forms of awareness based on different types of matter or existing at different scales of space and time. There may be cosmic scale intelligences that think in time frames of millions of years, or quantum scale consciousnesses that experience entire lifetimes in nanoseconds. Some of these forms of consciousness might be unimaginably advanced compared to us, beings who have learned to manipulate matter and energy at fundamental levels, who have decoded the deepest laws of physics, who have perhaps even learned to create new universes with custom-designed physical laws. Yet, in the context of infinity, even the most advanced possible intelligence remains just one note in an endless symphony of consciousness, exploring itself through infinite variations and possibilities. Now, exhale gently and feel your unique place in this infinite tapestry of awareness. This brings us to one of the most profound realizations of cosmic perspective. You are simultaneously insignificant and absolutely essential. In an infinite universe, you are one conscious being among infinitely many. Your individual existence spans just a few decades in a cosmic story that stretches across infinite time. And yet, you are irreplaceable. The exact pattern of consciousness that is you, with your specific memories, experiences, thoughts, and feelings, has never existed before and will never exist again in exactly the same form. Even in an infinite universe with infinite repetitions, the subtle differences in context, in the precise timing of quantum events, in the specific history that led to your existence, make you absolutely unique. You are the universe becoming aware of itself in one particular way, from one particular perspective, with one particular collection of experiences and insights that no other conscious being anywhere in infinite space and time can duplicate exactly. Every thought you think, every emotion you feel, every moment of wonder or love or peaceful contentment adds something new to the universe's growing understanding of itself. You are not a passive observer of cosmic reality. You are an active participant in the universe's ongoing exploration of what it means to exist, to be aware, to experience beauty and meaning. This perspective transforms everything: your daily life, your relationships, your moments of quiet contemplation under starry skies. All of these become cosmic events, opportunities for the universe to experience new forms of consciousness, new ways of organizing matter and energy into patterns of awareness and understanding. Take a deep breath and feel the profound responsibility and privilege of conscious existence. When you look up at the night sky and feel wonder at the vastness of space, you are the cosmos feeling wonder at itself. When you experience love for another person, You are the universe discovering new depths of connection and meaning. When you create art, music, or literature, you are reality exploring its own creative potential through the specific pattern of consciousness that is you. This doesn't diminish the scientific understanding of the universe, it enriches it. The same quantum mechanics that governs the behavior of subatomic particles also governs the neural processes in your brain. The same gravitational forces that shape galaxies and galaxy clusters also keep your feet firmly planted on this small planet where consciousness first learned to contemplate infinity. The same creative processes that built the cosmic web from tiny quantum fluctuations also assembled the complex molecules, cells, and neural networks that allow you to experience this moment of peaceful reflection on cosmic vastness. Recent discoveries in neuroscience and quantum biology are revealing deep connections between consciousness and fundamental physics. Some researchers propose that consciousness itself might be a basic feature of reality, like mass or electric charge, not something that emerges only in complex brains, but something that exists at every level of organization in the universe. If this is true, then every particle, every atom, every star might have some rudimentary form of experience. The universe would be conscious all the way down to its most fundamental levels, with human consciousness being just one particularly complex and self-aware expression of a cosmic property that permeates everything. Let your awareness expand to encompass this possibility, like consciousness recognizing itself in everything around you. This brings us to what might be the deepest mystery of all. Why does anything exist at all? Why is there a universe instead of nothing? Why do the laws of physics have the particular forms they do? Why is reality structured in such a way that matter and energy can organize themselves into galaxies, stars, planets, and conscious beings capable of asking these very questions? Some theories suggest that all possible universes must exist, that reality includes every conceivable set of physical laws, every possible configuration of space and time, every imaginable form of matter and energy. In this view, our universe exists not because it was specially created or designed, but because everything that can exist must exist somewhere in the infinite multiverse. Others propose that consciousness itself plays a fundamental role in shaping reality, that the act of observation, measurement, and awareness somehow participates in determining which possibilities become actual. This would mean that conscious beings like you are not just passive observers of a pre-existing universe, but active participants in its ongoing creation. Whether either of these theories is correct, one thing is clear. The mere fact that you can contemplate these questions, that you can experience wonder at cosmic vastness, that you can feel peace and connection while gazing at stars, suggests that consciousness and cosmos are intimately connected in ways we're only beginning to understand. Perhaps the universe created conscious beings because it needed to be observed, understood, and appreciated. Perhaps the long history of cosmic evolution, from quantum fluctuations to galaxies to planets to life to consciousness, is the universe's way of developing the capacity to know and experience itself. Breathe deeply and feel yourself as the universe's own sense of wonder and curiosity. As we approach the end of our cosmic journey, it's worth reflecting on how this perspective changes our daily experience of life. When you know that you're made of stellar material, forged in the nuclear fires of ancient stars, it becomes harder to feel disconnected from the natural world around you. When you understand that the same forces shaping galaxy clusters also guide the formation of snowflakes and the growth of trees, the boundary between you and the universe begins to dissolve in the most beautiful way. When you realize that your consciousness is the cosmos becoming aware of itself, every moment of awareness becomes a gift, not just to you but to the universe as a whole. This doesn't mean that human problems and concerns become insignificant. Rather, it means they become part of something larger and more meaningful. Your struggles and joys, your relationships and creative expressions, your moments of doubt and breakthrough, all of these are ways the universe explores what it means to be conscious, to care about something, to find meaning in existence. The cosmic perspective doesn't diminish human experience. It reveals it as a fundamental part of how reality knows itself. And in quiet moments like this one, when you're peacefully contemplating the vastness of space and time, you're participating in what might be the universe's favorite activity, the simple joy of conscious existence, the peaceful awareness of being part of something infinitely beautiful and mysterious. Now take a deep breath and feel the infinite cosmos breathing with you. As dark energy continues to accelerate the expansion of space, the far future of the universe will be very different from today. Galaxies outside our local group will disappear beyond our cosmic horizon. The cosmic web will be stretched thin and eventually torn apart. Stars will exhaust their fuel and burn out, leaving behind cooling white dwarfs, neutron stars and black holes. But even in that distant future, consciousness might find new ways to exist. Advanced civilizations might learn to extract energy from black hole rotation, or from the quantum fluctuations of empty space itself. They might develop forms of consciousness that can survive in the ultra-cold, nearly empty universe of the far future. Some theories suggest that even black holes eventually evaporate through Hawking radiation, returning their mass energy to space in a process that takes vastly longer than the current age of the universe. In that ultimate far future, only quantum fluctuations would remain, occasionally creating random configurations of particles that might, given enough time, evolve into new forms of complexity and awareness. The universe might be cyclical, with new Big Bangs emerging from quantum fluctuations in empty space, or it might be eternal and infinite, constantly creating new regions where complexity can emerge and consciousness can evolve. Whatever the far future holds, one thing seems certain: the universe has shown a remarkable tendency to develop ever more complex and beautiful forms of organization. From quantum fields to atoms, to molecules, to stars, to galaxies, to life, to consciousness, each level builds on the previous ones, creating new possibilities for structure, beauty, and awareness. You are part of this cosmic trend toward greater complexity and consciousness. Your existence represents billions of years of cosmic evolution, culminating in a pattern of matter and energy sophisticated enough to contemplate its own cosmic origins and destiny. Exhale slowly and let yourself rest in the profound privilege of conscious existence. As our journey through infinite space and time draws to a close, we return to where we began, with you, looking up at a starry sky, feeling both small and infinite, both temporary and eternal, both separate and utterly connected to everything that exists. The universe is vast beyond imagination, possibly infinite in both space and time. It contains mysteries we're only beginning to explore, forms of matter and energy we're just discovering, possibilities for consciousness and complexity that we can barely imagine. And yet, in all that vastness, there is this moment, your awareness here and now, peacefully contemplating the cosmic story of which you are such a beautiful and essential part. The ancient light from distant galaxies has traveled billions of years to reach your eyes tonight. Quantum fluctuations from the first moments after the Big Bang have grown into the cosmic web that cradles our galaxy. The patient work of stellar nucleosynthesis has forged the elements that make up your body and your world. All of cosmic history has led to this moment of quiet awareness, this gentle recognition of your place in the infinite mystery of existence. You are not lost in the universe. You are not separate from it. You are the universe itself, organized into a temporary pattern of consciousness, breathing quietly under ancient starlight, feeling peace and wonder at the magnificent reality of which you are forever a part. The universe is infinite, and so are the possibilities it contains. Among all those infinite possibilities, one of the most beautiful is the capacity for conscious beings to experience peace, love, wonder, and connection. You embody that possibility. You are infinity, becoming aware of itself, one gentle breath at a time. Now, let your eyes drift closed and rest in the infinite embrace of cosmic consciousness, knowing that you are home, you are safe, and you are an irreplaceable part of the most beautiful story ever told. If you enjoyed this journey, don't forget to subscribe, leave a like, and share your thoughts in the comments. Sweet dreams,